Hey folks, and welcome back. Today we're going to be doing some acceleration practice problems. So we're going to be building on what we worked on Monday and Tuesday of this week. So go ahead and make sure that you have this Kami doc open, and we're going to be working through a couple of example problems. So before we get into those example problems, though, we need to take a look at our equation to make sure that we know what all the different parts are. So our equation is that acceleration A, so this is acceleration, all right, that's the A, is equal to VF. This is our final velocity minus the initial velocity. So final, that's at the end, initial, that's at the beginning, minus the initial velocity. Oops, it's in a T there. Is divided by the time. Okay, so that's how we're going to solve for that. Now, I'm not going to ask you all to solve for time with this equation, but I will ask you to solve for the other three. So acceleration, final velocity, and initial velocity. So let's take a look at some examples of solving those. And again, you should be following along, pause the video if you need, and copy these as you go. So in the first one, we're solving for acceleration, okay? So a car accelerates from 0 to 10 meters per second in 4 seconds. What is its acceleration? So let's always start off by writing the equation blank. So A equals VF minus VI divided by the time. Okay, so final velocity minus initial velocity divided by time. Now let's read through our problem and see if we can figure out what those pieces are. So a car accelerates from 0. Okay, if it's starting at 0, is that final or is that initial? That's going to be our initial. Okay, so 0, that's the initial velocity, minus, or sorry, not minus, to 10. So it starts from 0 and it ends at 10. So that's going to be our final velocity. So we're starting at 0, ending at 10 in 4 seconds. So this is going to be our time. What is the acceleration? Okay, that's what we're trying to find. We don't know that. So now we need to fill in our information. Acceleration is equal to the final velocity. Remember, the final velocity is what we ended at. That is 10 meters per second minus our initial velocity. What was our initial velocity? 0 divided by our time, which in this case is 4 seconds. So we've got 10 minus 0, which is still 10 meters per second divided by 4 seconds. And then we're going to go with 10 divided by 4, which is, if you use your calculator if you need, 2.5 meters per second. I did say up here in the directions to make sure to show your work. So make sure that you are showing that work. And you will not get full credit if you don't. Make sure you use correct units. Oh, I did not use correct units. This should be meters per second squared because it's an acceleration. And then finally, circle your answer so that I can see it, right? So circle that answer so you can see what's going on, all right? So make sure you do all of those parts in order to get full complete credit. Okay, next one, solving for initial velocity. Okay, solving for initial velocity is going to take a couple extra steps, all right? But let's go ahead and make sure we start off the right way. Acceleration is equal to VF minus VI divided by time. All right, a car accelerates at 3 meters per second squared to a speed of 15 meters per second in 5 seconds. What is the initial velocity? So it's accelerating at 3 meters per second squared. There's our acceleration to a speed of 15 meters per second. Okay, 2a. That is telling us that this is the end velocity, so this is going to be our final velocity. In 5 seconds, there's our time. And then what is the initial velocity? That's what we don't know. So what we need to do is we need to go in and plug in our pieces. So our acceleration is 3 meters per second squared is equal to the final velocity, 15, minus the initial velocity, divided by the time, which is 5 seconds. Okay, so we've got everything filled in here. Now we need to go through and solve. Okay, let's think back to when we did our speed and velocity equations. When we were trying to find the number on the top, which in that case was distance, but in this case is the initial velocity, we started out by multiplying by the time. And that's because, again, we need that initial velocity to be on one side of the equation by itself. So we need to multiply both sides of the equation by 5 seconds. And I'm just going to use the little color line to kind of break up the steps here. Okay. When we multiply both sides of the equation by 5 seconds, on the right side, that's going to cancel out. It's green here. We'll see easier. Those are going to cancel out. And so we're left with 3 times 5. Okay. So we've got 3 meters per second squared times 5 seconds is equal to 15 meters per second minus VI. Okay, so now we need to go ahead and do this over here on the left first. Okay, so what's 3 times 5? So that is going to be 15 meters per second squared times, or sorry, not times because we just did that, is equal to 15 meters per second minus VI. All right. So what's our next step? Well, we need to get VI by itself. So we need to minus 15. These 15s are going to cancel out. And so we're left with 15 minus 15. Well, I think that you all can do that. What's 15 minus 15? That'd be 0 is equal to negative VI. Okay, and we need to flip the signs here. So this is negative VI. So we're just going to flip the signs. That becomes positive. This becomes negative, but 0 can't be negative. And so we're just left with VI is equal to 0. Okay, VI is equal to 0. That's our final answer. Now let's say that this wasn't a 0. Let's say that this was 5. So it was 5 is equal to negative VI. Right. Well, that would mean that it'll have to be a negative number over here. So this would be negative 5 is equal to negative VI. So what that really means is that VI is equal to 5. Okay. So just make sure that you're getting the signs right, because remember, directionality matters when we talk about velocity and when we're talking about acceleration. All right. Okay. Last one. Last one is very similar, but this time we're trying to find the final velocity. Okay, this time we're trying to find the final velocity. So a car accelerates at 10 meters per second squared for 9 seconds. If its initial velocity is 5 meters per second, what is its final velocity? So again, let's start off with our equation. Acceleration is equal to VF minus VI divided by time. Okay. So now let's go in and find our pieces. Accelerating at 10 meters per second squared, that's acceleration. For 9 seconds, that's time. The initial velocity is 5 meters per second, and we don't know the final velocity. So let's fill those numbers in. 10 meters per second squared. By the way, 10 meters per second squared is a large acceleration. That is a very large acceleration. You would feel 10 meters per second squared a lot. All right, for 9 meters per second. Okay, so let's see. We don't know the initial velocity. I'm sorry, the final velocity. We do know the initial. So subtracting 5 meters per second divided by 9. Okay, so, and that's 9 seconds. So what's our first step here? Well, again, just like we did on the prior one, we need to multiply by this 9. We need to get rid of the denominator. So we need to multiply by 9. All right, so those are going to cancel out. Okay, so we're left with 10 meters per second squared times 9 is equal to VF minus 5 meters per second. Okay, so what's 10 times 9? 10 times 9 is 90. And so when we multiply these, this is going to end us up with 90. And one of those seconds is going to cancel out because we're multiplying it by time, right, by 9 seconds. This is going to be left with 90 meters per second is equal to VF minus 5 meters per second. Okay, so what's next? We're going to be adding 5 meters per second because what's the opposite of subtracting? It's addition, right? So we need to add here, which means we need to add here. And so those are going to cancel out. So we're left with 90 plus 5. What's 90 plus 5? 95 meters per second is equal to the final velocity. And there is our answer. Now let's think about that. That makes sense, right? Because we started off, our initial velocity was 5 meters per second. We accelerated at 10 meters per second squared for 9 seconds, right? Which means